This is an ad hoc video in which we're going to show the networked robots in action. In particular, we're going to monitor the accelerometer in both pitch and roll and also the Z acceleration. And here we have the Microraptor, and we can see the blue LED is blinking, meaning that it's connected to the network. We have a networked robot. It happens to be the only one connected for now. Everybody else is off. And everything is good. We're ready to go. Now what I'm going to do in the following video is I'm going to be, tilting. Actually, this is a roll. And this will be a pitch. And you're going to see graphs, strip charts, and also Java Bean and NavBall in action. So let's go over here and we can see the screen, and we see on the left hand side of form we see the NavBall. Right now nothing's happening. Why? Because we're not connected. So a key point is, in order to talk to this Microraptor, we need to tell our system that we want to talk to this particular Microraptor through the network. Again, we have a lot of robots that we can talk to. Okay, so what I'm going to do is go over here, and we have a pull down menu, and we can see that. And the particular ID that we're looking for starts with a 99, easy to find right here. So we pick it. Now look at the text field on the right hand side. It'll get filled, and you see that we have a description that it's a Microraptor, an built-in Albuquerque, and some attributes about it, plus its code is 120, which lets us know that the TCP IP address is 192.168.100.120. so now that we've got that selected, I'm going to hit the connect button, and we're going to get a connection, a WebSocket connection to the robot through the WebSocket server and also the frontline Java server. And there's a lot going on behind the scenes. I'm not going to get into details. We'll talk about those later, and we've talked about them in some other videos. Now here we see 3 charts. This is important. We're using JFreeChart, which is a great Java library for producing sophisticated graphs. And they have a chart that's called a strip chart, which is exactly what we need. You'll see that in a minute. And right now there's nothing going on because we're not connected. So now I'm going to press the connect button. Here we go. And let's see what happens. You can see that our NavBall is now changed a little bit, and a key thing is to look at the pitch and the roll. There's no activity, so the strip charts, the dynamic strip charts, are just showing a constant. So what I'm going to do next is do a pitch. So coming over here, let's see the Microraptor. I'm going to do a pitch, and what I'm going to do is move it like this, and then I'm going to pitch in the other direction. And as I'm doing that, we'll have a history of what I just did on the strip charts, and you can see that right there. So we went in opposite directions, and the strip chart recorded that over time. Now the beauty is the time is actually the date, hours, seconds. Okay, and it keeps moving, and I'm going to do that again. So this is the pitch facing downward. Okay, now I'm going to get face upward. Keep it there for a little bit. Okay, and release it. And there we go. Now let's go take a look at the NavBall. This is very interesting. So for pitch, look at the degrees. Okay, so this is up. Okay, pointing up. horizontal, pointing down. Okay? There we go. And you can see the activity on the strip chart. Now next we're going to do a roll. So take a look at the strip chart on the roll and you'll see that it's flat, there's no activity. Now I'm going to focus on the Microraptor and I'm going to do a roll like you see right here. Two things. First of all, we see the NavBall indicating the roll, and then I'm going to set it flat, and then I'm going to do roll in the other direction. So you can see the NavBall responding. Now notice the response is very fast. We're measuring every 200 milliseconds. And I'm going to let it flat. Now this whole history is recorded in the strip chart, as you can see. So the strip chart shows the roll as we move the Microraptor in different ways. Now I'm going to move it again. So I'm roll to the counterclockwise and flat and roll clockwise. You can see the history right there. Okay, it's going to drop. Now, we also have the Z Accelerometer, and for that what I'm going to do is take the Microraptor and carefully hold it like this and move it up and down, like so. So as I'm doing this, we should get a history of acceleration in the Z direction. Also probably some in the X and Y, which are pitch and roll.
I couldn't find direction on your list.
There you go. So you see the acceleration on the Z direction was captured, and it's you can see some semi-large values. You also see acceleration on the pitch and roll, which are X and Y, but mainly on the Z axis. Now I'm going to do a rapid acceleration. Let's see how far up we can jump. So that was very rapid. You see the amplitude increase substantially, indicating a high acceleration. Okay, going back here, let's just go ahead and do a pitch facing downward, pitch facing upward. It's almost instantaneous response. This is a roll. There we go. Rapid response. Every 200 milliseconds. Now these dials, one of them is going to show the gyro, so we'll also capture the gyro too. And the other dial that says Z axis is actually either pitch or roll. Let's see which one it is actually. And you can see that it's actually pitch. So we can also show results with the voltmeter Java bean. So we have the NavBall Java bean and the voltmeter Java bean. By the way, this form was designed using JForm Designer. Now we do have other fields in here which we'll use later. These are for sending commands. But before we send a command, we need to stop measuring. Like if we want to send a command to, for example, move forward or reverse or just test commands. We have that capability through the WebSocket connection. Again, in the background, this is a Java application, standalone, can run on any machine. It connects to the WebSocket server. It can connect through a tunnel, and right now it's local on port 285555, and connect to the WebSocket. Get it, and since it's providing the unique ID, it'll get connected through the frontline TCP/IP server to the robot and it can communicate with the robot, measure all the sensors, and we have Java code that does this. Okay, now in practice, in theory, we could have multiple of these Java applications running, and each connected to a different Microraptor simultaneously. This is the power of the network robots. Okay, so that completes our demonstration.